Welcome to another episode of Neural Networking with Konverge AI. Today, we are excited to be joined by Adrish Sannyasi, Vice President of Customer Solutions at Rhino Federated Computing. Adrish brings with him a wealth of experience across AI, cloud, and healthcare technology. Over the years, he has held key leadership roles at industry giants like Google, Oracle, and Splunk, working together at the intersection of innovation and impact. His deep expertise spans product strategy, enterprise architecture, and AI driven healthcare solutions, making him a true thought leader in this space. Adrish, it's a pleasure to have you with us today. First question, Adrish, that I have for you is for the non technical audience, can you describe what exactly is federated learning and how does it challenge the centralized mindset that has dominated AI and machine learning for years?
Yeah, that's a good introductory question. It's first of all, it doesn't challenge the centralized mindset. It's an extension of centralized mindset to make things better. So think about in a centralized database environment, you have to have data in a single place, and then you work on that. You apply pre-processing, apply training and inference, all from a single database. And what is happening in federated learning, you're doing all those things, but you're doing across multiple databases. And those databases could be in your own organization, maybe in a different geographical region, or it could be working with a partner, and the partner has a database that you want to take advantage of to build your model. And federated learning provides a framework or capabilities to make that happen seamlessly, so that you can take advantage of the data that you have and the data that you may not have in a single place, but you want to take advantage of that data while you're building your model. So that's pretty much it.
Right.
So now if you think about in terms of the going to the next step, is way to think about it is instead of you are getting the code, getting the data to the code, you are sending that code to wherever the data is, and you are developing your model. The rest of the stuff is pretty much the same. You have to do all the basic machine learning concept that you will learn. You can reuse. There is no difference in terms of the concept. The only difference is this, instead of you having data in one place, data is in the different places.
Right. So the primary perspective of the federated learning is that can we say that if your data for domains like healthcare, or there may be some other domains where the data, for example, in the case of healthcare, it may lie at the patient records or any other data that may lie at different providers or different places or different geographies, but you want to build and solve that business use case by building a model which takes into considerations this data which is located all across.
That's right. So now, while you are doing that, it is not just about running that training. So if you think about it, it's running that pre-processing, running inference, or running just analytics, because you want to may have different types of needs, or in a machine learning project, you have to do all those steps. So it's doing the full life cycle across all of these data sets, and while you were doing the training or while you were doing any other workflows.
You made a very good point that we need to consider the full life cycle, and whenever we talk about the full life cycle with the business folks, then they say that this is something that can be difficult to implement, or how does this tie to getting the business benefit out of the problem that you are trying to solve? So in federated learning, this is also that I have heard from many business leaders, that though it sounds promising but tough to operationalize. So in your view, when does it make more business sense than traditional models, or what kind of AI use cases that it can be used for, and what are some of its pros and cons?
Yeah. So now think about, as you are doing any AI project, you want to start not with the solution, you want to start with a business problem that you want to solve. You have to have some kind of AI strategy and some of the business goals that you want to achieve. For example, you want to maybe building a better model for your revenue enhancement, or you want to build models for customer satisfaction, or in case of healthcare, it could be better model for your clinical decision support, or in case of life science companies, it could be, improving the drug discovery cycle, or accelerating the clinical trials and so on. So it has to be first have to have a business goal, business strategy. Somebody in the organization has to be responsible for those KPIs. So things that you do any analytics or machine learning project, you still have to do those. So now let's say you have a model, and that model may not be generalizing today because it don't have enough data sets, or you cannot access the data sets that you have because of the privacy, security restriction, or sovereignty rules, because European countries have those kind of sovereignty rules. You cannot move the data out of the country, or in a situation that there's some precious data that lives in somebody else's sites. So let's say in case of life sciences, the data could be in a hospital systems, or in case of you are doing, let's say, fraud detection for banks, and then not every bank will share data with each other, but the model might benefit from seeing the data across the banks. Or in case of manufacturing companies, it could be, you're doing, let's say, predictive maintenance, and that, the machine data resides in different locations, and you cannot centralize those. So have a business strategy, and then if you see this kind of constraint, that should trigger that this federated learning might be a solution. So, business objective, problem, solution, the approach that you generally follow in any project, you want to follow that. And then if you have a good AI strategy, or have another project that really worked, and you want to improve the project, that's actually a better way of using federated learning. If you don't have anything, if you don't have any centralized model, or even any centralized code that you can't be using, then it's very hard to go directly to federated learning, because federated learning works on top of the data and the model that you might already develop using public data sets, or even your own data sets, and then you're expanding from there. So that's kind of a right situation for federated learning.
So I get that what you're saying is primarily there is a prerequisite checklist that you need to take in order to start using federated learning. So as an enterprise or enterprises, what is there a framework, or where you can go and check out this prerequisite checklist already, which is present in order to start applying federated learning? Are there any frameworks that the enterprises can look at?
Yeah, there are different kinds of frameworks. And there is a lot of research done in this space by Google, Apple, and also NVIDIA. and they created a number of open source framework that you could start experimenting with. One of the frameworks is called NVIDIA Flare, for example, but there are other frameworks as well. And that can give you an idea. If you run it in a simulated fashion, it can give you some idea about what is actually needed in terms of making that project successful. It has some good documentation and some a code base that is open you can look at to get started. So that's like one piece of it. However, there are other things that you need to worry about. For example, federated learning is not just about the machine learning framework as described. There are security concerns, right. Like you are sharing data with the frame in this, to the code. So you need to have some kind of governance in place so that you are not giving access to the data to everybody, only to certain code or certain types of situation where this code could be accessed. And then there are other technologies that you might have to integrate here. For example, there's a concept called privacy enhancing technologies, and there are a lot of research and also practical implementation done in this space, especially by cell phone companies and others. It's called differential privacy. That kind of guarantees that data will not be leaked from the model. Right. And then there's a couple of other things that you have to worry about is you want to share the data if the data for a certain region or certain groupings is less than a threshold. Let's say I have only 10 patients for certain conditions. I probably don't want to expose that to anyone because of a variety of reasons. And there are other technologies that might be important here, because let's say you are an AI developer and you have a model and you want to enhance the model using the data sets from multiple places using federated learning. You probably want to still maintain the IP on the model. So you have to make sure that those IPs are not getting leaked, model parameters are not getting leaked to different places. So there's a concept that is coming to life is called confidential compute. So confidential compute is a way to run things in a way so that I can operate on encrypted data in the memory rather than decrypting the data in the memory. So there's a bunch of different technologies that is required to make this successful. So the first of all is the security, the privacy technologies, and of course I also discussed previously that you actually need to worry about the whole end-to-end life cycle, like you do in a machine learning project, like you have to worry about data engineering, part of machine learning, and then connecting to data sources, and then so on, and then doing evaluations. So all the things that you have to bring into this environment as well. So those are the things that if you do traditional machine learning, that's like a checklist of 90% checklist. Yes. And then the 10% is this kind of privacy technologies, confidential compute technologies, and data governance and setup, etc.
Makes sense. As there is data involved, I think it's the privacy and security that's where it is coming into picture. Now going forward, so sometimes what happens is whenever there is a technology, you can apply it in certain domains. It works across domains. So I have heard from many leaders that in domains like healthcare or manufacturing or maybe finance, federated learning had shown some real promise. But are there any domain-specific use cases which are a good fit?
Yeah. Because of the privacy and regulations, federated learning got started in a lot of these regulated industries like healthcare, life sciences, manufacturing, etc., or financial services. However, it actually got started by Google in a cell phone. So, it's called cross-device federated learning. What we are doing in our environment, in our enterprises, is called cross-silo. But it actually started with the cross-device by Google, where they can do the machine learning training on individual phone, and then can aggregate the model weights to create a model that's used in the most of those Android phones. Apple does a very similar thing, and I think that Facebook is doing all very similar approaches as well. It's generally adopted now in healthcare, life sciences, and also in financial services. The reason for that is obvious, that data sharing is difficult in these domains. And you cannot just send your PHI from hospitals to AI developers. So because healthcare and life sciences has a lot of private information, this federated learning is popular in this kind of domain where PHI or PII data is paramount, and also in say financial services as well. But that's the one particular notion of federated learning. But this could be applied across other industries like automotive, or for manufacturing industries, where getting the data in one place might be difficult because of a variety of reasons. The data might be in multiple clouds or multiple machines in the factories, which is not easy to centralize. And you can better run this thing as an edge device, edge client for federated learning. That's why I think it has a lot of promise in manufacturing, automotive, self-driving car industries as well. So privacy is one angle. The second angle is this not difficulty of centralization of data because of a variety of reasons. It could be for regulations or geographical problems, or this could be a problem like there's a lot of data that is coming out of a device, or maybe a lot of data living in a different clouds or different data center, which is hard to centralize. It's very expensive to centralize data, as you know. So those are I think the situation where any industries could potentially use it, irrespective of whether it's the data is private or not. It's a lot of different ways that it could be utilized for your business purposes.
Great. So I was also curious how this federated learning start, and how does it where now coming to the enterprises. So if you could throw some light on the story, how it started and now how it is being taken by the enterprises, that would also be something awesome.
Yeah. So one of the popular use cases, every hospital has their own EHR data. Those EHR data is hard to share. So let's say, or like not just EHR, it could be imaging data and other related data sets. And let's say you want to develop a better cancer classification model or cancer detection model. In that situation, what happens is a couple of parties comes into and create a called consortium. So consortium is like a collaboration mechanism that has some kind of legal agreement and stuff that this organization will work together to develop this cancer detection model. So now everybody in that organization is agreed to share whatever the data they have to this model training process. So first step is to make sure that those commercial agreements are in place. Second is once you make sure that is there, and the second thing is to make sure that the IT and security organizations within those institutions are good with this kind of approach, because there is some kind of education, then to be confident that platform or tools they're using is secure, private, they're not leaking the data, etc. So that there's a security check. That's actually good. It's almost like doing a vendor validation or any project. You do that generally, and then this is an important project and this will be done anyway. So that's the second step. So now next, when you have the security things are completed, then you would worry about the provisioning of tools and resources. For example, you need to have, maybe you are sharing data through various mechanisms. Like you may have a cloud storage, you may have a relational database, you may have a data warehouse like BigQuery or Snowflake or Databricks. Those could be your data source. We need that AI developer to connect to those kind of data sources in a consistent way. Once you have that, then you have to worry about how the compute get provisioned. So compute could get provisioned in different ways. You could have we can have a virtual private cloud that sits on top of these data sets, and then that may have a VM where all the different software gets installed, or it could be a serverless environment. Depending on the capabilities of the platform you're using, this could be provision. So, but something needs to be provisioned, some compute. Whether you're serverless or VM based, that's a different story. And that compute needs to have access to these data sets in a secure way, of course, privacy preserving way. So that's a kind of a provisioning. So now let's say you have this kind of the basic setup in place. Now, everything that you do in a machine learning project, you have to do pretty much the same thing here. You have to worry about data engineering, like these data sets could be in a same format, could be in a different format. So this is schema validation or data transformation needs, making sure data has high quality or data is cleaned, and then it could be utilized for machine learning. So all the things that you do in a traditional machine learning project, you'll be doing very similar thing here in terms of making the data transformed in a way that can be utilized by a model training process. And then this model, one of this consortium member or maybe a third party will write the AI training program that's going to take that data sets and can run the local training. So what's happening is you have the code, and code could be containerized, and that container gets sent to all the different sites, and then it runs on top of these data sets and creates the model parameters, so the model weights, right? And then this model weights gets aggregated in a central orchestrator or central aggregator, where you create the global model. And then once the global model is created, you have to store it in a secure way, possibly an encrypted way, so that nobody else can see this outside of these participants. And then maybe you want to run inference on the data on this model within this framework, or you can take the model weights and run inference in another cloud, or maybe in an on-prem, maybe in a different environment. It's possible. But you also have a very similar thing that you do in a machine learning project. Like training is not really a one-time activity. You kind of have to have this infrastructure in place so that whenever you're using this model in a production, let's say in a real cancer patient situation, you may have to come back and redo the model or retrain the model. So having an ability to retrain the model or fine-tune the model would be important as well as in any other centralized environment. One thing I'll mention is that you not necessarily have to do machine learning in these settings. Some people just do analytics. So let's say instead of doing analytics, from one database, you're doing analytics in a federated fashion across multiple databases. So it can be, your problem might be you want to count number of patients or you count number of transactions to get some insights. And that could be one of the use cases as well. That's a much more simpler, but you're doing a very similar federation concept. That means you are calculating your metrics in the different sites, and then those metrics gets aggregated by this central orchestrator or central aggregator, and then you're producing the final metric. So it's a very similar approach that you follow in terms of where averaging the weight or aggregating the weights. It can do the exact same thing. The third thing you could do is as an AI developer, you can use now this infrastructure for variety of different use cases. For example, as an AI developer, you might want to distribute the model for inference
Right.
to different places. And think about this, in this case, the central orchestrator is a distribution mechanism, orchestration for this AI model that can then distribute it into all the different sites. And then sites can run the model on their own data and create the output. However, they would not be able to see the model weights or download the model weights. That's you would call it confidential inference. But it's nothing to do with federated learning, but you're using all the exact same framework, exact same architecture and mechanisms to perform this kind of confidential inference. For example, let's say you have a language model, and that language model has an API which is running from a single cloud or single data center, and your customer doesn't want to send the data to that API. So how do I, in this kind of situation, how customers can still take advantage of this language model that you develop or you fine-tuned? The way to do that is you can containerize this model, you can encrypt the model parameters, and then you send that to different sites. It runs in confidential compute environment so that nothing is leaked. And then that customer can produce and take advantage of, take the inference out, and then your container gets destroyed and there is no stress of the model. So that's the way we're seeing that you can use the same infrastructure that is used in federated learning for this kind of confidential inference type of use case.
Right. So this all is bringing a lot of operational and implementation together, operationality and implementation together. If we really have to build the use cases, deploy those, and maintain also in a production scenario. So what are some of the biggest implementation challenges that you have seen teams run into, both technically and organizationally, when trying to deploy federated learning?
Yeah. So the first thing is, let's address the organizational first. Obviously, we just talked about you need to have an AI strategy linked to business, and you need to know why you're doing it as a clear before you start doing it, so that everybody is motivated, everybody knows why you are doing it, and there is no question of funding, etc. Got to get allocated. Those are important things that you have to do as an organization. Also, some people might be skeptical in the beginning as well. So there's some education involved and to aligned. And if you have a business objectives, it is much more easy to get aligned than if you're just running it like a research project. So that's like a number one thing. The second is in this scenario we have, you probably want to also create like a partner. You need to have partnership has to be part of your business strategy. So let's say you are working on a drug discovery model and you want the pathology data from a hospital systems. You need to have those kind of existing relationships in place, so that it's not like a cold call to your partner, that suddenly hearing about yourself or your business. You need to have some kind of existing business relationships with this partner, or you are establishing this business relationship as a part of your AI strategy. So that's why the strategy is so important, because this is going to drive a lot of the actions that you need in order to actually get started in any AI project, and including this kind of machine learning or federated learning or analytics projects. So that's the number one thing we have to worry about before you even start the technical implementation. So now, in terms of the technical implementation, you have a choice of developing some of these things, yourself, using multi-cloud, but it's a very difficult oftentimes. That's why the platform like Rhino and others, coming into picture, where we help our customers in giving this kind of ready-to-use infrastructure in place, so that they don't have to worry about connecting to data sources, doing security, privacy, orchestrating things, aggregating model weights and all those things. Those are the things that are taken care of in the background as a part of this platform. So that's what the advantage of using this kind of platform as a starting point. Or if you want, you can just use build yourself. That may take a lot of time, but that's also okay as well, as long as you're following the best practice approach and you're taking a risk of security, privacy, and then so on. You can develop it yourself as well, or consortium could develop their own platform as a part of their cost or part of their build process. So there's two options available based on what your goal is, and how fast you want to get things up and running, and what kind of risk model, and also how you want to develop and maintain things, like what part of the stack you want to maintain versus what part of the stack you might want to outsource to somebody else.
Right. So I guess now we have talked about the first where federated learning started, then we went into identifying the domain, then we said that okay, we have identified our domain, then let's say we have identified the problem, we put the problem into production, solved all the technical challenges that you mentioned, and now we are set for doing the evaluation, right? Because now the model and the federated learning is in production. So I have read about some concerns by a few teams on performance drop in federated setups, and how do these models hold up in real world use cases like forecasting or anomaly detection, some of these use cases. And with data staying local, what frameworks do you recommend for evaluating accuracy, fairness, or drift, or any other evaluation parameter?
Yeah. So the first thing is federated learning is a highly studied field now in computer science or in machine learning in general. So a lot of the challenges regarding data heterogeneity, how to handle, how to aggregate the model weights, that's getting studied, and there's a lot of validation now that proves that the federated learning actually improves the generalizability of the model, rather than decreasing the evaluation metrics in any fashion. It at least the same or better in most of the research paper that is published recently. One of the things I'll mention is that some of the problems in the data sets that might result into a bad model, those are actually same in federation or in case of non-federation centralized settings. For example, if the data is bad, if the data is not structured in the right way, or you have the different types of schema or different values let's say I want to describe a customer. And if you describe customer in one organization in a certain way, you call a new customer as new, and then other person calls active, then you have to figure out whether new and active is actually the same or not. So these are the things that actually comes into picture when you are doing this kind of heterogeneous data, dealing with heterogeneity of the data. And that's why one of the things that we invested in as a company is to, a mapping functionality, where I can map all the heterogeneous values into a standard value so that machine learning can operate on standardized values. And that actually resulted in a lot of benefit for our customers, so that customer don't have to worry about all this, data engineering aspects of this kind of transformation, and model becomes better because of this. So you agree? I agree with you. There are a lot of this kind of heterogeneity issues that may result into bad model performance. And you have to worry about that in the beginning and make sure you have the tools in place to avoid this kind of problem. The second thing that you mentioned is around the evaluation metrics. The evaluation metrics that you use, like F1 score or an AUC, ROC curve, and all these things, this can be easily applied across the federated network as well. Thing that you have to worry about is here you have to calculate the intermediate metrics first using local data, and then you have to aggregate the intermediate metrics to create the global metrics, so that you understand what is the capability of the global model is. So there are some work involved, and that's why this concept of central orchestrator becomes important, because central orchestrator can orchestrate all this different code that you need to run, and then aggregate the results in a certain ways, so that could be understandable, and that could be not look like a foreign thing. It should look like exactly the same thing that you have done in your centralized settings. So ability to work on that would be one of the things that you need to worry about. But those are tools that are available in the market to do this kind of federated evaluation.
Right, right. So we could see that there are ways, like you said, that we can always use to navigate through the risks, and also apply the same techniques that we already know from an evaluation parameter perspective to federated learning. Now, going forward with Gen AI and now agentic AI on the rise, do you see a convergence where models like LLMs might benefit from or even require federated architectures?
Yeah. So think about where all the current models are developed first using the pre-trained using the internet data. Then after that, to do the post-training, like a supervised fine-tuning or parameter efficient fine-tuning or reinforcement learning, they actually use a lot of their private data. Private data means data that is, either created by an annotation organization, or maybe a human is reviewing the data or creating the data. And also they're taking a lot of different databases which are not public, but creating the relationship with, let's say, Reddit and other companies to get the data sets that might be useful. For example, the reason that coding is so valuable or become so popular in GenAI, because there's a lot of the public and private data available for coding domain. But for coding domain, it is available because of the code is actually open source. Well, now think about, I need to solve a problem in drug discovery. I need to solve a problem in the cancer domain. I need to solve a problem in diabetic domain. Those data sets are not public. Those are private in different places. So in order to fine-tune my model, for a particular domain, I really need to get access to this data set. So one of the ways to get access to data sets in a good privacy preserving way is to use this kind of federated architecture so that you can send your initial model weights to the sites that has the data, and then you can run this training in a confidential compute environment so that nobody can see your training code or see your model parameters, and then you can then aggregate those model weights and create the fine-tuned version of the model. And that could be utilized within your own organization because it ran against your private data or maybe the private data of that consortium. Now all the members of the consortium now have a better fine-tuned LLM that can be utilized for their enterprise work, and that helps to reduce their risk of hallucination, and also it will reduce possibly the cost of running it because this model may be much more much more smaller and unquantized model compared to the large model. And lastly, they can actually evaluate the model against whatever evaluation metrics they have for that use case. And that's actually one of the huge, that's not just doing the training, but also evaluation across the sites will give them more confidence on the use cases. So I think this is the part of the GenAI strategy. I think if it makes sense, organization might consider this kind of approach for fine tuning and evaluation.
Both the two problems that you said, are something that people are trying to solve with the LLMs. One is the hallucination one, which is and the second one that you talked about, how do you trust and evaluate the responses. So this is very encouraging to hear that federated learning can be applied here, and you can look to solve these two critical issues in the LLMs. So last,
I'll one here in terms of people are talking about agents, and of course agent is not going to be solved tomorrow. It may take 5-10 years in certain domains to actually solve the agentic problem. So one of the things that you can think about, like an agent, instead of getting data, the agent needs data, right, to have a better response for the questions or execute the task. And those data sets might not be in one place. The data sets might not be in a single format or single schema. So federated approach could be beneficial here in terms of accessing these data sets, using a single API layer where all the complexities is hidden behind the federation, but it's presented in a nice API-driven way so that the agent is only looking at one API. It is much more easier to execute things that way rather than if the agent has to go to all the different places. Dealing with heterogeneity is difficult for agents. So using the federated approach, you could create this kind of a single virtual layer of API that could be beneficial for this kind of agentic applications.
Right. So the last question that I had for you is from a CXO mindset point of view, where since federated learning is gradually gaining attention and it's a really unique way of looking at data and AI, especially from a long-term success point of view, what advice will you give to the CTOs or even a CEO or a CDO on the future of federated learning?
Yeah, so one of the things that we all learn from, where the big companies are developing models, so the first thing they did is that they have access to a lot of data, which is fortunately was open in the internet. So it's a good head start. And after that, if you think about it, a lot of companies have spent enormous amount of time in have a human evaluator create the data, create synthetic data, and you could see that Meta has just acquired a company called Scale AI, which is basically a data labeling company. It's a data generation labeling. Think about that. The implications for that is they realize that the real gem here is the data and data labeling, and we need that for reinforcement learning or any kind of fine-tuning that you are doing for your problem, right? And that's kind of becoming the almost like a pattern. Like I have a pre-trained model, and nobody really starts from the scratch anymore. You have a pre-trained model, and then you take that and do supervised fine-tuning or instruction tuning or reinforcement learning for your use cases. In order to do that, first thing you need is a good data sets, and sometimes labeled data, sometimes unlabeled data. So how an organization can get those data sets? Because as a life science company, I may not have access to all the data that I need. So I may have to go to my competitor oftentimes to possibly create a consortium to get access to the data set so that everybody in the consortium gets benefit for the creation of this fine-tuned model. And then I may have to go to a partner. I may have to go to a health systems to get the data. So creating this partnership should be part of this AI strategy so that you have a data strategy for AI, and that data strategy would drive the partnership strategy, and then that partnership strategy drives the federated computing or federated learning strategy.
Right, right. So I think this was a great discussion on federated learning where we talked about the domains to be applied, how the use cases, what are the deployment challenges, how different it is from machine learning, and how the distributed data it's something that we can use and apply. Where is the perspective from a agentic AI / LLM architecture coming into picture? And what kind of mindset does an organization have in order to apply federated learning? And also we also talked about the prerequisite that checklist that you should have and tick the boxes before even starting about thinking, before even starting to think about federated learning. So thank you, Adrish, for spending the Friday morning with us, talking about federated learning and taking us through the complete life cycle of federated learning. Thank you very much.
Yeah, have a pleasure to have a conversation. Thanks for inviting.